Hey, everybody, what we're going to do today is learn how to use Google Sheets to graph experimental data and then also to graph a model of data like we're going to have with our tidal wave project. What we're going to do first is we're going to talk about a bunch of experimental data, okay? And I'm going to use data that is height in meters, as the x-axis and the time in seconds that it takes for something to fall from that height in meters to the ground. Okay, so my x-axis is actually going to be the height in meters, and I have it labeled y in m for meters, and I specifically am going to put experimental data at the top here so that my heading tells me what it is. That's my height in meters, that's my independent variable. And then the time it takes to fall that length, that height, is going to be the time in seconds and also the experimental data set. Okay, so we're going to start by doing our X data, and you can type all this data in, and the same with the time, but there are some shortcuts you can take. For example, if the data is evenly spaced, like mine is every 0.250 apart, you can type in the first few and then not picking the zero, because sometimes it doesn't work right when you pick the zero, but picking 3 different data where they're apart the same amount and the same amount as the rest of your data. If you grab them all, this little square will show up, and when you go over it, you'll see a crosshairs. And if you just grab that little dot with the crosshairs and drag down, you can make the data expand and show all these points that are apart by 0.25. And that's a lot faster. As far as our time in seconds, we're going to have to type those in because those are not regularly spaced, because we got them off of, in your case, you'll get them off of the internet, but in my case, well, I got them off the internet too, but it's not tidal wave data. So I'm going to do that, and I'm going to pause the video while I do that and then come right back. Okay, so now you have a set of data that we can graph, okay? On the x-axis, the one on the left, and on the y-axis, the one on the right. So what we're going to do is highlight the 2 columns, A and B. You can click and drag over, or you can click and then shift-click to get both of them in. And you're going to select both of the columns, and then now that they're highlighted, you're going to go up here to Insert, and you're going to go down to Choose Chart. Google Sheets is smart, and it will try to pick a good type of chart for your data. And it did pick a pretty good type of chart for our data here, because what they've got is a smooth curve. Okay, you can kind of see the data points show if I hover over it. We're going to fix that in a minute, but you can kind of see what happens, right? There's a nice curve upward and outward, but it's flattening as it goes. The first thing we're going to do is I want my data to show up. So I'm going to go over here and notice the chart editor has come up, okay? And here's where it shows the chart type. And it shows that on my x-axis is the y in meters, and on my y-axis, which is called series in Sheets, the time in seconds, okay? So what I want to do is put some nice dots in, not just have them show up ghosty like that. So I'm going to go to Customize. I'm going to go to Series. And again, series are the Y values. And down here, you can say, I want points. And see, there's no point size here. Circle is chosen as my point shape, so I like that. So I'm going to go down and make points that are 7 pixels, okay? And then we can see here that we have a nice graph, and the points that I actually graphed are connected. Okay, these lines between them aren't really that important. You can have them connect, but they aren't like a fit because they're not a function. Other things you can customize are chart and title axes, and you'll need to have an axis to your graph in the end, and you also will want to have things like, the series are the Y values, so we just did that. The legend will tell you what data is what color and what shapes. And then you'll want to have labels on the vertical and horizontal axes, things like that. Actually, that's in here. Axis titles are in here, the chart title. And they automatically generated one here. Somewhere you're able to do, you click, and then you can do a chart subtitle, you can do a horizontal axis title and a vertical axis title. All of these, because this is a particularly simple graph, were automatically put in, but I can always change it. I can click on this and edit it over here. Okay, so anyway, now that I've got my first data graphed, okay, that's the easy part. Now we're going to go and we're going to model our data. Okay, so in this case, of this scenario, I'm going to use the same time values because they're convenient, and it's not, with my kind of function, it's not important how far apart spaced these are. Whereas when you are doing your data, okay, you're going to do the maxes and mins of your graph, and you're going to use those to fit the sinusoidal model. But for me, it doesn't have to be anything special because there aren't any maxes and mins with this kind of graph. So what I'm going to do is I'm going to grab that data and I'm going to copy it down here. Just what's important when we are graphing more than one set of data on the same grid is that all the x-axis values are in the same column of data. So we have to put our new x-axis columns in there, and for some reason it didn't like that, so let's do that again. I'm going to grab all this data, I'm going to copy it, maybe I forgot to copy it, and then I'm going to paste it. Yeah, that worked better that time. Okay. All right, so I need all my x-axis data, which is the y, or the height in meters here. On the other hand, I cannot put my second set of y-axis data, my second set of times, in the same column as this, because it will just see it as the same bunch of data and graph it as one set of points. So what I'm going to do is I'm going to go to C, and I'm going to come across from this data, and I'm going to put my y-axis data starting in this column to match up with these times over here. Okay, so how do I do that? Well, I'm calculating these values because I have a model that's going to fit this scenario, okay, of the time that it takes for a body to fall from a certain amount. And what we're going to do in order to calculate these values, we're going to put an equal sign in the beginning of the cell that we want to work in, okay? And that equal sign puts us in function mode so that now Sheets knows that I'm writing an equation now for it to calculate values for me. So the equation that I need is a square root equation. So I'm going to write SQR, and then what comes up are square root equations. So what I need is the positive square root of positive number, a simple square root. So I'm going to click that one. And then it comes up with a parentheses in capital letters, and it wants a value. Well, what we're going to put in for that value is not a number, although it could handle a number. If I put in a 9 there, it would calculate a 3. But I'm going to put in an equation, okay? And so the first thing in my equation is a 2. I have to multiply a 2 times my x variable. So the first thing I'm going to do is I'm going to write 2 and then shift 8, which gives me this star, and that Sheets recognizes that as a multiply. Then I'm going to tell it that I want it to figure out from my height data. And in order to, what do I have to do that is I'm going to go over here and I'm going to click in this first height data, the one that's across from the one I'm doing. What that does is it makes a variable. Now, since it knows it's in formula, it makes a variable out of the cell here. So that's why it says A20, because this is cell A20. And this equation says take A20 and multiply it by 2. And when I finish it, whatever I get, it'll be taking the square root of it. But I have one more operation. I'm going to multiply 2 by A20, but then I'm going to divide them both by 9.8, which happens to be the acceleration due to gravity. Now I'm closing it. So it's going to take my A20, it's going to multiply it by 2, and then divide it by 9.8, and then it's going to take the square root of all of that. And of course it's 0. A20 is 0 here, so when we calculate this, it probably should come out to be 0. Let's see what happens. It does. Okay, so that's good. And now to get the rest of my data, I can go back to what I did in column A for the first set of data by grabbing it, putting my crosshairs on the square, and then once I have it, dragging it down. What that will do is that will copy the equation down, but it will use, instead of using A20, it'll use A21 and then A22 and then A23, etc., until it has calculated something for all of these. Now, if yours doesn't automatically come out to be 3 decimal places, you can go up here and click either this to decrease the number of decimal places it shows, or here to increase the number. Since we usually work with 3, that's why I put it like this. So now what we have is we have calculated data, and you can see that this data is not crazy numbers compared to what we actually got. But it's a lot easier to see it if we put it on a graph. Okay, so we now have a table of data. We have a blank column in the middle. Oh, we have to title this column of data. So we're going to go up to the top here. And this is still time in seconds. So I'm going to write T in seconds. But then I'm going to put in parentheses model, because this came from an equation. Okay, and notice how my headings are bold and centered. You can do all that up here in this editing thing. I clicked the centered here, and then when I grabbed those, and then I clicked bold so that they became bold, just to be able to see better. Now what we're going to do is we're going to draw another graph. But before we do that, we're going to get rid of this graph because we're not going to need it anymore. So now if I want to graph both sets of y values, the 2 time columns, against the 1 y column, or the x column, which is y for height, I'm going to grab all 3 of those columns. Okay, and then just like before, I'm going to go up to Insert and click Chart. Now, Google Sheets is sometimes good at picking how to display the data, but not always. So let's see if it does a good job now. If not, I'll tell you what to do. So I'm going to pick Chart. It's calculating, and as unsurprising, it didn't pick a good way for us to display this. Okay, what we want to have is a curved line chart. So see, over here in the chart editor, it shows a column chart. We're going to change that. So now I'm going to change it to smooth line chart. The other thing it did is it seems to be duplicating the data, probably because we have 2 levels of data here. It's doing it kind of twice in order instead of making the x-axis very ordered, directly from 0 to 4. So what we're going to do is we're going to come over here and we're going to say, okay, this is weird. The x-axis doesn't seem to have any data in it, and the y-axis has all 3 pieces of data in it. So what we want the x-axis to be is the y in meters, experimental data. So we're going to go over here and we're going to click this. And we're going to say, okay, we want the x-axis to be y in meters. So it fixed that. That's pretty good. But then we don't want there to be a y value that is that. So we're going to get rid of that one. Okay, and now we're looking at something that looks like what we would expect it to look like. Okay, and we might want to customize it. Okay. The good thing that we have here is we've got a y-axis that gives us the right y values from 0 to 1. All our y values are below 1. And we go from 0 to 4 meters in height. Okay. But now let's go over to customize, because remember how I wanted to see my data points over here? Let's do that. I'm going to go to series. Remember, series is your y-axis. And here it says point size, none. This does apply to all series, but I'm going to start by just showing my experimental data. So I'll make it 7 pixels. Okay, and so you can see the actual data points I graphed, but you can also easily see the fit. Okay, if I wanted to, I could go to the other model and I could change the shape of it, maybe make it a triangle or something, and then change the point size to 7 pixels also. Those triangles are pretty small. But when I look at that, the color seems to be enough to show the data a point apart. And I don't really need to see these particular points because they're not so important. So now I'm thinking, I don't really need points on my model. Having it be a straight line is okay. But in your case, with the sinusoidal data, you may want to have different shapes on each of them, especially with the ones where you're graphing the max and mins. It's nice to see where those maxes and mins are. But that's up to you. As long as it's readable, we can tell which one is which. But you do need to have a legend that says what color and what shape is what thing, okay? You also need to have, let's go back up to this one, a title, okay? A chart title. And this one doesn't have it for some reason, so I'm going to type it in, and I'm going to write y in meters versus time in seconds for a falling object. And then I'm going to say, okay, that was the chart title. Now I need to have a horizontal axis title. Okay, so I'm going to say, well, I need this to be y in meters. And I might even say height in meters, because that's more descriptive, and maybe in the title I would do that too. Height in meters. Then when I do the vertical axis title, I can write time in seconds. Okay, or maybe I can say time of fall in seconds, and that makes it a little more specific. Anyway, you can clean that up as much as you like, and you should really make sure that the points are clear, okay? So what we've got is a nice graph for our project. It looks like a really good model. I would say that your goal for your project is to get a model that is good, but it's not going to be this good because tides are governed by many factors, and they're going to be never exactly sinusoidal. Okay, plus, we're using an average to get a good max point and min type because tides are not as regular as a real sine cosine curve. However, they are sinusoidal enough for us to use our model for predictions about when the next high tide is going to be and when the next low tide is. Sometimes we can predict from our data when it's going to be a higher high tide than another high tide. All right, that should be enough to get you going. And you need to reach out to me if you have any questions while you are doing this, because sometimes it can be confusing.